back, everyone, for another episode of IGCSE Math ZNotes Live. My name is Devan, and I'm your host for this episode, along with our expert, Ivan Zelich. So, Ivan, please introduce yourself.
Thank you, Devan. Welcome back, everyone, to the 13th episode. So, the second last episode of the series. We'll be going through statistics today, and as Devan said, my name is Ivan. So, we've introduced each other's 12 times, so I guess But anyway, I completed a master's at the University of Cambridge doing pure mathematics, and for this time I'm taking the IGCSE mathematics. So without further ado, as I've said the past 12 times, let's get right into it. Okay, so main concepts for today are kind of histograms, frequency density, frequency kind of problems, and finding means and upper quartiles from data and graphs. So it's not too much, but it's honest work. Okay. Okay, so histograms. So basically, histograms displays frequency of either continuous or grouped discrete data in the form of bars. So basically, one thing that it's important to note is, well, it's said here, but the frequency of the data is not the y-axis. It's rather the area of the rectangles, or if it's continuous, area under a curve. So the bars are joined together and they can vary in width and height, but the height does not give frequency, of course, it gives frequency density. But frequency density multiplied by, in this case, age, would give you then the frequency in that kind of interval of 5 to 11, for example. We'll see problems of that anyway, but that's important to keep in mind. Okay, so as said here, frequency density is plotted is not the y-axis. Frequency is not the y-axis, but the frequency density is. The width, the class width is the interval. So the class width would be like 5 to 11 here, 11 to 16 there, and 16 to 18. Frequency density is the height, and to calculate area, it's base times height, class width times frequency density. Okay, so there are some measurements from data that we can extract. One of them is the mean, or the average. It's the sum of the values on the number of values, and it's a great way to kind of, if you want to understand like where the center is of data, it's kind of, that's what that would measure. There's also the median, which is kind of in some sense a similar kind of estimate, but it's not the same. So if you arrange the data in ascending or descending order, the median would be the n+1 on tooth value. I think there's also this rule that if n is even, for example, then n+1 is odd, divided by 2, you don't get a whole number. So you would look at the two numbers on either side of that number that you get, and then you would average them. Is that right, Devan?
That's correct. That's correct. Yep.
Okay, cool. So mode is the most occurring value. Here, they all occur once. so is the mode just... Okay, right, so there's no modes. Range is the difference between the highest and lowest values. So 26 minus 10. That kind of just gives you the spread of the data. There's also other ones, but is the next lesson going to be like kind of standard deviation, or is that not?
No, that's in A levels. It's not in here.
Okay.
Yeah.
So yeah, there's also another one. Yeah. Okay. And now and finding mean in group data. So, I mean, you guys probably know exactly what group data is, but basically, we'll see examples later. It's not clear in some sense how you get the sum of the values, but when you have, like, say, the frequency of some interval in which the values can occur, then you kind of take that midpoint and multiply that frequency, and gives you an estimate of the sum of the values in that interval. and then you divide by the total number, which are usually given. So you don't have to add them in that case. Okay, cumulative frequency. So yeah, so cumulative frequency. So if you're given us, say, a frequency distribution table, so for example, score of frequency. So the score of 1 is obtained twice, score of 2 is obtained 5 times. Cumulative frequency is you keep a running total. So score 1 is obtained twice, and therefore the cumulative frequency is 2. Score 2 is obtained 5 times, so the cumulative frequency is 2 plus 5, or indeed 2 plus 5 is 7. And similarly, 7 plus 4 is 11, 11 plus 2 is 13, etc. So you kind of add like a little triangle here. And so you would plus these two values, etc. And yeah, 7 plus 4, and yeah. And keep that cumulative frequency going. Lower quartile. So if you have the cumulative frequency table and say it's from a score from 0 to 100, then the lower quartile will be the 25 position, the 25th percent position, and so you usually asked to estimate maybe what the upper quartile, the lower quartile is, and you could basically just look from the graph and draw these little lines and figure out what they are. The interquartile range is in some sense like another kind of central where kind of your middle frequencies, middle values lie and how often they appear. That's kind of what the measurement is. So it's another central measurement kind of thing, and it's the upper quartile minus the lower quartile. It gives you kind of like a central thing, as I said. Okay, so those are the concepts, and I guess what's good about stats is that the concepts and the problems are they're directly applicable, rather than say in some questions where you've got to do some actual problem solving. Okay, so we're given a situation where we have 200 cars, and we've given a ranges of their speed. So that's on the top of this table. So at the top of this table, we're given speed. And we're also given the frequency of the said speeds in a distance, in an interval. And so we want to estimate the mean. So basically, a good estimate of the mean, well, we need the sum of the values. So we know that speed between 0 and 20, there's 16 cars. So what you could say, and this is a good estimate in some sense, is that the 16 cars are probably distributed pretty evenly, and so if 16 times the midpoint, or the average between 0 and 20, so the center, would be a good estimate of the total number in that interval of speeds. So to calculate the estimate of the mean, we'll do that. So we go 16 times 10, 34 times, well, the midpoint is 30, etc., and add them all up, and then divide by the number of cars, which we're given is just 200. So that's the goal. So we do that. So 16 times 10 plus 34 times 30 plus 62 times 42.5. The average of 40 and 45 is 42.5. And we keep doing that. Divide by 200. And we get the answer is 41.4 kilometers per hour. And in this case, because you had a really round answer, 41.4. It's 41.4 is okay, Devon? 2 decimal places or something?
Yeah, it's okay. It's okay.
Cool. Okay. So now we have to use the frequency table. So this is part B, and complete the cumulative frequency table. So the cumulative frequency, as I mentioned, is you keep adding like frequencies. So, you have to keep a running total. So yeah, we have 16 here. That's obviously, if V is less than 20, then it's 16. If V is less than 40, then it's 16 plus 34, which is 50. And so you can continue like that. So in the next instance, we'd go 50 plus 62. So that's the number of speeds between 40 and 45. And similarly, we'll add 58 to get the next value. Or you could have done 196 minus 26 as well, because you know that it have to be that way. So, and that's how you get your cumulative frequency table. And now, using this data, we could then draw a graph, which is actually the next question. So on the grid, draw a cumulative frequency diagram. Of course, it's much easier to have it when you have the table with you. So for the table here, and so we need to be careful here. So what we need to do is actually draw a cumulative frequency graph. And as Devan pointed out to me, these graphs are actually continuous. They're like smooth. So I've drawn them with lines. So basically, what I've done here is I've put, okay, so we know when the speed's 20, so between 20, we have 16. So I guess the first thing you would have to note is to figure out what scale these grid lines correspond to. So you see there are 5 grid lines, and it goes from 0 to 20, so each grid line's worth 4. You get to 16, you go on the 4th grid line, and this will be our first point. And so, yeah, and then we can continue like that. So we can keep putting the points in for the graph. Because when you put the points in, then you can kind of just draw a smooth graph between the points. So now the goal will be to actually
Ivan.
Yeah. Yeah.
So I checked the marking scheme for this question. It says that it's considered correct if the graph is a reasonable increasing curve or polygon through their 6 points. Does it mean it has to be smooth?
Okay, well that's good. So you would recommend them just doing lines or whatever is easier?
Wait, so when it says polygon, it means that it doesn't have to be smooth, does it?
Yeah, I think so. Yeah.
Oh, okay then. Yeah, I guess. Yeah, that's considered correct then.
Yeah. Well, I guess. Look, I guess it's whatever is easy. If you just put the points in without putting the lines, like, then just draw like a curve, an increasing curve here that goes through those points, and yeah, that's all you really need to do.
Yeah.
I guess what Devan's point is that it has to be increasing, which is important, because obviously you keep adding to get the cumulative frequency. It's an increasing function. So long as your graph's increasing, as Devan's pointing out, then it's okay.
Yeah.
And it could be a polygon. I would say it makes a lot of sense to just, because it's easier to draw. It's hard to draw straight lines.
It's much more easier.
Yeah. Except I don't think I'll be able to. Let me try to draw the curve. That's
Though you have a choice if you want to draw in the polygon way or in a smooth way. It's really it's your preference.
Yeah,
Though
exactly.
both will be considered correct.
Yeah. You can draw a better curve than me, but yeah, that's. I guess your point is fair. It's like the point. This cumulative frequency diagram represents you want to use these discrete data, but somehow get eventually like continuous data, and so drawing straight lines is a kind of an inaccurate representation of what it would look like. But yeah, fair enough. Cool. So now we have to use the diagram to find an estimate of the upper quartile. So we have a diagram, and so we got a 0 to 200. So we need to find 75th percent. That's at 150. So we're going to use wherever my mouse is. There it is. So 150. So it occurs right about here in the midway point between 160 and 140. We can then draw a line across, and we get here. And so it seems to be at around 48 is where it would seem like that lies. So as I think we spoke about this, Devon, it's absolutely fine to be estimated, right? I mean, that's
Mm-hmm.
from our
Yeah.
diagram as well. So yeah, it seems to be around 48. And so long as you justify it, I guess, would you recommend they're just putting it on the diagram themselves, or just putting the answer?
In the exam, I think you're expected to make the straight line there in the cumulative
Yeah.
frequency.
Okay.
Just that.
Cool. So yeah, I guess that's important, because if you get a different answer, at least they see why you've got the different answer. Okay, and the number of cars with a speed greater than 35. So what we need to do is we need to find 35. So speed 35 here. And what does that correspond to? That corresponds to about 42 right here, because it's about halfway between 40 and 44. Oops. Something like that. Oh, sorry about that.
Yeah, it's okay.
Let me just raise. Hopefully it does. Oh, it raises the whole thing. Great. Yeah. Oh, geez, laser pointer now. Yeah, but if you just draw it like we did the previous one, it should look around 42. And so 42 would be the number of cars less than 35, and so greater than 35 would be 200 minus 42, which is 158. Okay, now we have part C, which is 2 of the 200 cars are chosen at random. So I guess the key point here is to note that 2 of the 200 cars. So we'll see why. Find the probability that both have a speed greater than 50. So at 50, we can draw a line, although we actually don't need to, because the line is very much in a position right there. So we have 50 is about here. And, well, it's about halfway between there, actually. So it seems to be about 170 right there. You can draw that line kind of thing. Yeah. So it seems to be at 170. So 170 cars have a speed less than 50. So 200 minus 170 have a speed of greater than 50. So it seems like the probability is 30 on 200. However, because you're choosing it from the 2 cars, so once you get that one of the 30th cars, then you only have 199 cars, and 29 of those will have speed greater than 50. So the probability is the product of 30 on 200 times 29 on 199, because you take one car away that's greater than 50 speed, so there's 29 cars left, and you're taking 1 car out of the total, so there's 199, and that's an estimate of the probability. So it's a better estimate than 30 times 200 squared, say. So if you just said 200 in general, I think. So yeah, and you can leave it as a fraction, as I've done here, but you could also write as a decimal place. Yeah. Anything you want to add there, Devon? Or
Yeah, no more.
no more. Okay, cool. Okay, so part D, a new frequency table is made combining intervals. So we have we're given these intervals, and we have to draw a histogram to show the information in this table. So of course, I stressed it out probably like 5 times at the start, but this is frequency density. Yeah. And I remember when I did the question, I was like, okay, so I have 50 here, but there's no 50 on the y-axis, because obviously, this is frequency density. It's not frequency. So we have to make a table of frequency density. I mean, this will be the easiest way to do it. So we get our table. We want to put frequency density. So how will we do that? Well, frequency is the area, and so if our density was some value, then 40 times that density is 50, for example. And so therefore, to calculate the frequency density, we have to divide the frequency by the speed. in this case, or well, the top, the interval of the speed. So 50 divided by 40 is 1.25. And then we have an interval of 10 here, and frequency is 120. So in that interval, it's 120 on 10, which is 112. And then we have 30 with frequency of 30. So it's just 1. And now we just have to draw a histogram. So those are bars. We can put our points in. So the first point is, well, always with these with these graph questions, you need to figure out what the scale is. So there are 10 markers between 0 and 5, so the scale is 0.5. And so if we want 1.25, we would need midway between 1 and 1.5. So this is why we've marked here as the 1.5 level. The next and the width is going to be 0 to 40. The next one is going to be 40 to 50, and it's going to go all the way to 12. 12 will be right around there. So 4 markers up from 10 is going to be where 12 is. And the last one, from 50 to 80, we have a frequency density of 1. So that'll be at the second marker from the bottom. So right there. And yeah. So that'll be a histogram. Is there anything you want to add there, Devin? Anything I should have put in?
No, nothing. I think
cool.
That's enough. Yep.
Okay. Yep. Cool. So, question 6. The following table shows time taken by each of 120 boys to solve a puzzle. We have to calculate an estimate of the mean time. Again, we kind of explained it to it, so it's a straightforward process. The thing I would say is I put 120 on the bottom because I presumed all boys participated, but there could be this little trick where it's actually not 120. But I think in this case it definitely is. But why I said that is because make sure that that your answers that it matches. If you add the frequencies, make sure that they add to 120. So again, just to remember, so the first value here, 25 times 38, is because we average 20 and 30. We get 25, so the middle, and multiply by 38. Next one's 32.5 on 27, 37.5 times 21, etc. Just have to take the middles and multiply by the frequency, and then ensuring that the total frequency is 120. That's our mean. Okay. And so the answer 40.46 seconds. So 2 decimal places, Devin, in this case, or?
Yeah, it's okay.
Okay, cool. Okay, so I think this is our final question. So on the grid, complete the histogram to show the information in the frequency table. So we have our frequency table. Again, our standard procedures, we have to figure out frequency density. That's frequency on the interval. So 38 divided by 10 is 3.8. 27 on 5 is 5.4. 21 on 5 is 4.2. 16 on 20 is 0.8. And finally, 18 on 40 is 0.45. And so now all we have to do is fill in with the correct widths and the heights. So we can see, well, it's a good it's definitely a good thing that we have 3.8 written here already for us. So it's one verification of our calculation. Again, we need to figure out scale. In this case, it's 10. 10 grid lines represent 1. So is that 10? Yeah, 0.1 is each increment. So 3.8. So the next one's 5.4, and so that'll be 4 up. That's why the height's there. And it's from 30 to 0.5. So 30 to 35. So 5 markers across. And if we continue like that, so the next one's 4.2. So it's 2 up from 4. And the width is going to be 5 again. The next one's going to be 0.8, so 2 down from 1, and the width is going to be 20. And finally, we have, it's going to be 0.45, so between the 4th node and the 5th node, I mean the 4th row, and the 5th, yeah,
0.4,
between
0.5.
Yeah, okay. Yeah, exactly. Between 0.4 and 0.5. And yeah, and then that'd be that, and it's from 60 to 100. Right. So that's it. I guess the whole point of it, as I mentioned earlier, was that there isn't much problem solving going on. It's more like applying the skills. So if you master the skills, you wouldn't worry about the stats section, I think. And yeah, and that's one good one to nail at least. We have one more lesson to go, which is going to be great, and I think that's going to be continuing stats, right? Devon? Are we continuing stats next lesson?
Yeah, sorry, my connection is not doing well.
No worries. Yeah, so
are.
we're going to continue stats next lesson, and yeah, anything you want to add? Or I think we're pretty much
It's
done.
just when you
right?
draw cumulative frequencies or histograms, just make sure to be neat.
Neat. Yes, of course. Yeah. And yeah, I guess it's also good to put just as much working as possible when it comes to where you put your lines and stuff. Oh, you don't need to put working; it just has to be correct. I guess it's the best way to put it. They can bring a ruler, right?
Of course. Yeah,
Yeah,
they're allowed to bring
cool.
rulers.
Nice. Okay, cool. Well, I guess that's it.
Okay, so yeah. So that's it, everyone. Thank you for watching today's episode, and thank you, Ivan, for being with us today. Don't forget to check out our Instagram page, our website, and also join our Discord server. We'll see you this Friday.
Thanks, everyone.